Megaquake sparks, strange Cascade volcano pulses. Are eruptions next? By Browse News, September 2025. A world still shaken by the Kamchatka Megaquake. In late July 2025, the planet shuddered under the force of a magnitude 8.8 megaquake off Russia's Kamchatka Peninsula. It was one of the largest earthquakes recorded this century. Its rupture stretched across hundreds of kilometers of subduction zone, releasing colossal amounts of energy. The quake was so powerful that it not only generated tsunami waves across the Pacific Ocean, but also triggered seismic echoes that traveled deep into Earth's crust and mantle. For the people of Kamchatka, the immediate concern was survival. Infrastructure damage, coastal evacuations, and waves battering harbors dominated the headlines. But for Earth scientists, what came after the quake was even more astonishing. A strange cascade of volcanic responses that began rippling through the Pacific Ring of Fire and may now be reaching as far as the Cascade Range in North America. A chain reaction of volcanoes in Kamchatka. Within days of the quake, 7 volcanoes in Kamchatka erupted or showed intense unrest. Among them was Krasheninnikov volcano, dormant for centuries, which suddenly exploded in a dramatic ash column rising more than 6 kilometers into the sky. Klyuchevskoy, already known as one of the world's most active volcanoes, resumed activity with renewed vigor. Volcanic ash disrupted aviation routes, and plumes were tracked by satellites as far as Alaska. Volcanologists called it a parade of eruptions, a rare multivolcano, awakening not seen in this region for nearly 300 years. The timing was suspiciously close. Could the megaquake have shaken awake these volcanoes? Or was it coincidence? Multiple volcanoes that were already primed erupting in sequence. The mystery of the volcano pulses. What has puzzled scientists most, however, is not just the Kamchatka eruptions, but the mysterious pulses now being detected in volcanic systems thousands of kilometers away. In the Cascade Range of the United States, home to Mount Rainier, Mount Hood, Mount St Helens, and Mount Shasta, seismic networks have begun recording weak rhythmic tremors and changes in geothermal output. These are not large enough to be called eruptions or even precursors, but they are anomalies. At Mount Rainier, gas vents on the summit have shown faint increases in temperature and chemical changes. In Oregon's Newberry caldera, geothermal monitoring stations recorded unusual fluctuations in underground heat. Even at Mount Hood, sensors picked up subtle low-frequency tremors, described as volcanic heartbeat pulses. These patterns have left researchers asking a critical question. Did the Kamchatka quake send ripples that disturbed magma systems half a world away? How earthquakes can disturb volcanoes? The science is both fascinating and uncertain. Large earthquakes release 2 types of stress. Static stress changes, permanent shifts in the crust which can crack or compress volcanic systems nearby. Dynamic stress waves, seismic energy that travels globally, rattling magma chambers and volcanic conduits like a bell struck by a hammer. If a volcano is already near critical pressure, even a small nudge from these stress changes can be enough to disturb gas bubbles, fracture rock, or trigger fluid movement. Scientists compare it to shaking a bottle of soda. If it's already under pressure, a slight tap may cause it to fizz or overflow. But most volcanoes are stable and resist such disturbances. This is why not every big quake leads to eruptions. The critical factor is whether the magma beneath the surface was already restless. The Cascade Range on alert. The possibility that the Cascades could be responding to a quake across the Pacific is sparking intense monitoring efforts. The U.S. Geological Survey, USGS, has issued advisories that while no eruption is imminent, the signals should not be ignored. Mount St Helens, which last erupted in 2008, remains the most closely watched. Any new uptick in seismicity there draws immediate attention. Mount Rainier, because of its massive glaciers and proximity to Seattle and Tacoma, poses a significant lahar, mud flow hazard, if activity increases. Mount Hood, Oregon's tallest peak, is showing subtle signs that scientists call background unrest with irregular pulses. Researchers caution that these pulses could fade away as stress dissipates, or they could mark the early rumblings of a new eruptive cycle in the Pacific Northwest. Why this matters: global volcanic risk. The Earth operates as a connected system. A megaquake in one part of the world can send stress waves racing around the globe, nudging faults, stirring hydrothermal systems, and perhaps even shifting volcanic behavior far away. For communities living near volcanoes, this raises the stakes. Even if the pulses in the Cascades do not lead to eruptions, the episode underscores how fragile and interconnected Earth's systems are. A single seismic event can set off a domino effect that scientists are still struggling to fully understand. Scientists divided. Not all experts agree on the interpretation. Some argue that the pulses are natural background noise, amplified by heightened monitoring after the megaquake. Others see them as a genuine response, evidence that large earthquakes can act as a trigger or last straw for magma systems on the edge. Historical records show examples of both outcomes. The 2004 Sumatra megaquake was followed by eruptions in nearby volcanoes. While the 2011 Tohoku quake in Japan had limited volcanic aftereffects despite its magnitude.